This is video 1.7 on the lessons on how to do algebra. And what we're going to be looking at in this video is how to simplify algebraic fractions. And it is an important subject. It's quite difficult in grade terms. It's up at the top end of the GCSE, and it's also something you need to be able to do if you're thinking about doing A-level. Now, we see a lot of students make very fundamental mistakes when working through algebraic fractions. So the aim of this video is to show you where those mistakes lie so you can avoid making them, and also to show you what you should be doing instead. So we're going to start off as normal by looking at numbers. So let's look at this very simple example, 10 divided by 2. Now, we all know the answer is 5, which is fantastic, but let's think about how we get there. Well, we could write that as 5 over 1, and 5 over 1 is 5. Okay, but let's think about why we wrote 5 over 1. We knew that there was a common factor in the 10 and the 2, which meant we could divide both top and bottom, the numerator and the denominator, by that number 2. So if we divide the top and the bottom by the number 2, then the numerator becomes 5 and the denominator becomes 1. So that's what we've instinctively done. You can also have said that 10 divided by 2 is 5, but if you think about the cancelling aspect, is simplifying this fraction. Now, another way of writing that down would be to say, well, 10 is the same as 1 times by 2 times by 5, and 2 is the same as 1 times by 2. And this is where we start to see some problems creeping in. Students often taught that, well, if there's a number above and below the fraction line, you just cross it out because they cancel. But then what is replaced by that crossed out number? Now, if we were going to be doing something like 4 take away 2 plus 2, we can cross those out and say, well, they're nothing, because if you add 2 to negative 2, you get nothing. So often students think, well, we've crossed out that 2 and that 2, we've taken them away from each other, so there's nothing left. But that would leave 5 over nothing, and that's wrong. Okay, that is not the answer, because 1 you can't divide by 0, and we're looking for an answer of 5. So what's gone on here? Well, what we should have said, if you write that question out again, what we should have said is, well, if there's a 1 above and below the line, you can divide both above the number above and below the line, the numerator and the denominator, by the same number, in this case 1. Now if you divide 1 by 1, you get 1, and you get 1 there. Let's do the same for the 2. Let's divide the 2 by 2. 2 divided by 2 is 1, and 2 divided by 2 there is 1. So you're left with 1 times by 1 times by 5 over 1 times by 1, which is 5 over 1, which is 5. So this is absolutely wrong. Just cancelling and thinking that's 0, but this is correct. Now, putting in that 1 there had no real benefit, because if you divide 1 by 1, you get 1. So often when you're thinking about factorising and simplifying, you forget the 1s. You don't need the 1s there. But sometimes it's worth thinking about, because if you cancel the 2 there and you did think about, well, that disappeared, and you did make that mistake, you would have still been left with that 1, unless you didn't cross that one out as well. So let's look at another example of that then. 21 over 15. Now, why don't you pause the video now and see if you can split that up into factors above and below the line, the numerator and the denominator. You can include the 1 or not, it's up to you. Okay, I'm not going to include the 1. I'm going to do 3 times by 7 and 3 times by 5. So we can see there's a common factor in the numerator and the denominator, and that's the number 3. So we can say, well, 3 divided by 3 on top is 1, and 3 divided by 3 in the bottom is 1. So we've divided the top and the bottom by the number 3, and the fraction simplifies to 1 lot of 7 is 7, 1 lot of 5 is 5. So that is often what students do when they're taught how to simplify fractions. They're taught to say, well, look for that common factor, 3, and then divide by 3, and that gets you straight there. But that's what we're doing. So when you're crossing out, when you're taught to just cross those out, understand that when you cross it out, when you cancel in fractions, you're not saying, well, it's disappeared, it's become 0. It's actually become the number 1. It's very important later on when you're doing harder questions. Now I want to look at the next biggest mistake that we see students make, and it's on questions like this: 21 plus 15 divided by 3, or 21 plus 15 over 3. Now, if we don't add the top, which would be instinctively you'd say, well, let's add the values on the numerator first and then cancel. But if we leave them as split out like that, so we leave them as a sum on top, let's look at factorizing. Well, let's factorize the 21 and we can get 3 times by 7, and factorize the 15 and we can get 3 times by 5, and that's still over 3. Now this is the mistake which we see a lot, maybe not in this example, but when we come to do algebraic fractions, or what you would call algebraic fractions with unknowns or variables, they'll see, well, there's a 3 above the line and a 3 below the line, so we can cross that one out and cross that one out. And even if they do actually say that, well, that divides to make 1 and that divides to make 1, they're still made a mistake there. When you are cancelling fractions like this, and I'll write it out again, I might have got them in a different order this time, 3 times by 5 plus 3 times by 7 over 3, is that if you're looking to cancel or simplify by dividing through by a common factor, you have to divide every term in the numerator by that common factor and every term in the denominator by that common factor. So, as there is a common factor, the number 3 here, look, 3 times by 5, 3 times by 7, and 3 times by 1, in every term in the numerator and the denominator, then we cancel. We can say, well, 3 divided by 3 here is 1, and in this term, 3 divided by 3 is 1, and in this term, 3 divided by 3 is 1, and you're left with 5 plus 7 divided by 1, which is 12, which is the correct answer. So that's, if you are going to cancel using that approach, you have to have the same common factor in every term in the numerator and the denominator. Now, another way of approaching that problem, and the way that I think is the safest way, is to, once you have split the numbers into their factors, or you try to identify a common factor, you actually go ahead and factorize it. So if I'm factorizing now that top, the numerator there, and if you can't factorize that, then go and look at one of our earlier videos on factorizing. Then you'll see now we've got a product on the top, 3 lots of 5 plus 7, and we've got a 3 times by 1 on the bottom. So now when we divide the top and the bottom by 3, we cancel. The 3 divided by 3 makes 1, and the 3 divided by 3 makes 1. So we've simplified that fraction, and we're just left with one lot of that bracket, and the bracket is worth 12. So if in doubt, I advise a lot of students to, if you can't factorize it, then don't simplify it, because if there wasn't a 3 here, you wouldn't have been able to factorize it out. If that 3 didn't exist, then it wouldn't have been able to factorize out, so you wouldn't have been able to cancel. Another example, for instance, might be 8 plus 6 over 4. Now, again, it's too simple an example to actually worry about doing it this way, but it just illustrates the point. We can do 2 times by 4 plus 2 times by 3 divided by 2 times by 2. Now, there is a common factor there, the 2, so we can say divide that by 2, divide that by 2, divide that by 2. Or we can factor out the top and now simplify by dividing the top by 2. Well, 2 divided by 2 is 1 there, and 2 divided by 2 there is 1. So you're left with 7 over 2. Okay, so that's another example of doing it that way. Now, a very common mistake we see students making is if they've got a question like this, x plus 1 divided by x. Now, even if they didn't make the mistake with numbers, because instinctively it looks wrong and they can look at it and say, well, hang on, that's not the correct answer. With unknowns introduced or variables introduced, students repeat the mistakes above. So they'll see this and say, well, I've been taught if there's an x above and below the line, I just cross it out. So there it is, I just crossed it out. So I'm left with the number 1. Okay, and again, that answer's wrong. So don't do that. They're not equal. That's not correct. That's not the way that you simplify that fraction. If you're going to divide the bottom by x, you need to divide everything in the top by x. And what you would have got is this. X divided by x on top would be 1. And then you get 1 divided by x, and x divided by 1 on the bottom. And you're left with 1 plus 1 over x, which is mathematically the same, but it's not any more simple, and if we were trying to simplify the fraction, it hasn't actually helped. Okay, so don't cross out individual x's when there's more than one term in the numerator. You have to look for a common factor. Right. ax plus bx over x. Now, pause your video and see if you can work out how to simplify that fraction. Okay, well that fraction does simplify, because if you look at the numerator, each term has a common factor of x. This is a lots of x, and this is b lots of x, and the numerator and the denominator is 1 lot of x. So every term contains a factor of x, which means we can divide every term by x. So you can say this term divided by x, well, ax divided by x, well, the x divided by x gives us 1. 1 there, and the x divided by x there gives us 1. So this does simplify to a plus b over 1, which is a plus b. Or, and maybe safer, we could have, on the same question, factored out the x, and at that point, because we know we can factor, so there must be a common factor in the numerator. If that common factor is the same as the denominator, then we can then cancel at that point, or simplify at that point. So x divided by x is 1, and x divided by x is 1. And you get the same answer. So that one does factorize. Here's another one for you. See if you can simplify that one. See if you can simplify that one. And again, you would see, well, that's x lots of x, and that's 1 lot of x, so there's a common factor in the numerator of x, so we can factorize that, and we get x lots of x plus 1, and in the denominator we get 2 lots of x. So we see there's a common factor of x in the numerator and the denominator, so we can divide the numerator and the denominator by x, and we're left with 1 lot of x plus 1 divided by 2. Now you can put the numerator in a bracket or not. I tend to leave them in brackets because it makes it clear that that's one number. X plus 1 is a number, and that will become clearer, or that will become more important when we look at more complicated examples. Okay. Have a look at that question and see if you can factorize it. First, factorize the denominator first, and then see if you, once you've factorized it, if it can then, the fraction can then be simplified. So pause your video. Okay, well that denominator does factorize, and again, if you can't factorize that, please go and look at one of our earlier videos. And you get x lots of x minus 2 on the bottom. Now we're looking for a common factor in the numerator and the denominator now. Now you'll spot that the numerator is a product of the number x plus 3 times by the number x minus 2. And the denominator is a product of the number x times by the number x minus 2. So the number x minus 2 is in the numerator and the denominator. So we can say, well, we can divide the top and bottom by this common factor, x minus 2. And x minus 2 divided by x minus 2 is 1. And x minus 2 divided by x minus 2 is 1. So we're left with x plus 3 divided by x, and that can be in brackets or not in brackets, it's up to you. So that has been simplified. Now when students see questions like this, particularly if they've done enough, they've seen in a lesson a teacher crossing out x's, they might start doing this if they're doing it wrong. Now I'm going to put wrong to begin with so you know it's wrong. They might start saying, well, that x cancels with that x cancels with that x, and you're left with 1 over x minus 2. Okay, and you see that a lot, and it's a shame because often they've done some good work up until that point, and then they've completely misunderstood how to cancel fractions, and they start just cancelling, just crossing out x's above and below the line. Okay, so that is wrong, so avoid doing that kind of thing. Right, so now the questions can just get a bit more complicated. So there's a more complicated question. First of all, start by factorizing the numerator, and then seeing if there's a common factor between the numerator and the denominator which can cancel, so that fraction will then simplify. Okay, so how did you get on? Did you manage to factorize the top? Well, if you didn't, then you might have to go and look at our Factorizing quadratics video, or, in this case, our Factorizing the difference of two squares. Because x squared is a square number, and 4 is a square number as well. And you should be looking out for the difference of two squares when you're doing problems. It occurs a lot, and that will factorize to x plus 2, x minus 2. So if that was something you couldn't do, there's a video on that, or you can actually factorize those using normal quadratic factorizing, which there's a video on that as well. So I'm not going to spend any time on this video explaining how. So now we've got x squared, x plus 2 times by x minus 2 divided by x plus 2 times by x minus 2. So on this problem we can see what's common. Well, the x plus 2 is a common factor, so we can divide the top by x plus 2 and we can divide the bottom by x plus 2. And we can divide the top by x minus 2 and we can divide the bottom by x minus 2. And what we're left with is 1 lot of 1 divided by 1 lot of 1, which is the answer 1. Now for any A-level students watching, you may want to consider when this equation isn't valid, but I'll leave that up for you to do in your own time. Okay, so when you're simplifying fractions, you're looking for common factors. What we're not doing is crossing out x's and crossing out 4's. Another thing here would be tempted to say, well, that 2 can cross out with there like that. Now that would be wrong, so if you just, that is wrong. Okay, you have to cancel numbers by finding common factors, but the factor has to be in every term in the numerator and the denominator. So here are 4 questions for you to do now. I've factorized them for you so that you can just look for the common factor and then carefully cancel it. So once you've written them down, or pause your video, write them down, and when you have the answers, start again and I will go through them with you. Okay, looking at the top one then, let's look for common factors. Well, this has a common factor of 2, because 4 is 2 lots of 2. Now we could write this out as 2 times by A times by A times by B over 2 times by A times by B times by B. Now that's okay as long as the powers are quite small, but if that was a to the 100, you wouldn't want to write out 100 a's, so you'd have to deal with it in this way I'm going to show in a second. But in this particular question, that was possible. So 2 times by 2 on the bottom there. So now I can cancel above and below the line the numerator and the denominator with common factors. Well, that 2 can divide by 2, and that 2 can divide by 2. Now notice I didn't divide that 2 as well, because I've divided the top and bottom by 2. Just cancelled one pair. Now that a can divide by a, and that a can divide by a. That b can divide by b, when that b divides by b. And I'm left with a over 2b. Okay? So that's one way of doing it. But really, you should have been able to say, well, 2 divided by 4, well, divide the top by 2 and divide the bottom by 2, gives you 1 and a 2. The a squared divided by a is an a on top, and the b divided by b squared is b on the bottom. And that would have got you there in the same way. So that's what you would have had to have done if they were much larger numbers. Now looking at question 2, let's deal with the x minus 3 first. So the x minus 3 is a number that's common to both the numerator and the denominator. So if I divide the top by x minus 3, I get 1. If I divide the bottom by x minus 3, I get 1. And that leaves me x over x squared. Now, before we move on to the next question, is there anything common now? Well, there is, isn't there? Because there's x in the numerator and there's x lots of x in the denominator. So we can divide the top by x, and we can divide the bottom by x. And when you divide x squared by x, this power here becomes 1 less. There's a video on indices. Okay? So you'll see teachers crossing out powers, but that's okay when you're crossing out a square, but we'll look at a cube in a minute where you have to be very careful. Okay, so that's reduced by 1. So have a look at indices, video, powers and indices video, if you're not sure on dividing powers. And then we're left with 1 over x to the 1. Well, x to the 1 is just x. Before we go on to do question 2 and question 3, let's look at x over x cubed. Because if you don't understand what's going on, you might see a teacher say, well, let's cross that one out, and then you might say, well, when we did 1 over x over x squared, you cross that out to become 1, and we cross that out. So you might be tempted in this case to cross that out. But that's not correct. We can cross that out when it's a square because we take off the power 1, and then x to the 1 is just x. But when in this particular case, when you do x divided by x to get 1 on top, when you do x cubed divided by x, this power decreases by 1, so it becomes a 2. So we haven't crossed that power out, we've reduced it by 1. Okay, going back up to question 3 now. This is actually easier than the one above. You've got x plus 2 lots of x minus 3, and you've got x lots of x minus 3. So the x minus 3 is a common factor, so we can simplify it by cancelling it, dividing top and bottom by the same number, and we get x plus 2 over x. And then finally, we've got the a plus b lots of x, and then we've got 3 lots of a plus b times by a minus b. So again, the a plus b can cancel, and we're left with x over 3 lots of a minus b. So hopefully you got all 4 of those questions correct. Well, maybe you got that far on that question, but you have to keep simplifying until the fraction is as simple as it can be in its simplest form. Okay, spotted an error on the video. Well, I said x, but I wrote 2, so that should have been x plus 2 over x, not x plus 2 over 2. Now I'd like you to finish with 4 harder questions. Now these are harder because you have to factorize them first. So pause your video, copy these down, and then when you're ready, start the video again and I'll go through the answers with you. Now, hopefully you didn't find them too difficult. If you couldn't factorize the quadratics in the numerator and the denominator, then go and watch our earlier videos. Question 4 is a bit trickier, and it took a bit of thought. Perhaps that's the one you couldn't do, but we'll go through it once we've done the other 3. So let's start with question 1. Let's start with factorising that numerator. Well, x squared minus x minus 6, it's going to be a quadratic. So we know it's a double bracket. And x times by x will give us the x squared, so it's going to be x and x. Now we're looking for two numbers that multiply together to give negative 6, but add together to give negative 1. So the two numbers that multiply together to give negative 6, well, you've got 1 times by negative 6, negative 6 times by 1, negative 2 times by 3, and 2 times by negative 3. Now, only one of those pairs adds to make negative 1, and it's this bottom pair here. So the answer on top is x plus 2, x minus 3. So that's been factorised on top. Now let's factorise the denominator. Now, a lot of students can factorise the numerator because they have that, they practice this and they practice and practice and practice it, and then when they come to one of these questions, they find it difficult because they try and apply this method. Now it will work because you're looking for two numbers that multiply together to give 0 and add together to give negative 3, so it does work, but it's just so different to the kind of questions you're used to doing that you don't manage to get it correct. Whenever you get a question, regardless of what it looks like, even if it looks like a quadratic, you should always ask yourself, is there a common term first, a common factor first in both the terms? Now, there is a common factor in both of these terms. It's the number x. So we can factor out an x, and that leaves us x minus 3, because x lots of x minus 3 is x squared, because x times by x is x squared, and x times by negative 3 is negative 3x. Now we can see if there's a common factor in the numerator and the denominator, which there is. In this case it's the number x minus 3, so we can divide the top by x minus 3 to get 1, we can divide the bottom by x minus 3 to get 1, and we're left with x plus 2 over x. Now you can leave that in a bracket if you want. And that's as far as that one simplifies. But the shame of it is, a lot of students in an exam would get that far, and they would have got all the marks, and then they'll go and try and cross out those x's and say the answer's 2. So remember, you can only simplify if there's a common factor in both the terms. Now you might say, well, that is one term, it's in a bracket. Well, it's one lot of that, so there had to be an x in both of these parts of the sum if that was going to be able to simplify. Looking at this question, we've seen this already. I chose it again just in case you weren't particularly good at difference of two squares, but it is something you need to get good at. So there's no need to simplify or factorize the denominator, but what I've done, I've put it into a bracket, and often I will put the denominator into a bracket to remind myself that's one number, and then the numerator simplifies to x plus 2, x minus 2, and then we see there's a common factor of x minus 2 in the numerator and x plus 2 in the denominator, because remember that's one lot of x plus 2. So we cross that out. Oops, crossed out the wrong one. Let's make that a minus and make that a plus. That is x plus 2 divided by x plus 2 is 1, and x plus 2 divided by x plus 2 is 1. So we're left with x minus 2, which can be in a bracket if you like. Okay, well that is x minus 2 divided by 1, which is x minus 2. Okay, on the next one then, double bracket. It's a quadratic, it's going to be an x there and an x there, and we're looking for two numbers that multiply together to give negative 10 and add to give negative 3. Well, that's going to be x minus 5 and x plus 2. So well done if you got that bit right. And in an exam, if this was worth 4 marks, even if you got the bit factorised at the top, you'll get marks. Now, we're not teaching you just to pass exams, but if this was exam technique, I'd say, well, go as far as you can in every question. And even if you can't fully simplify it, at least factorise the numerator and the denominator, and you'll get a lot of marks. Now, the denominator is x there, and we're looking for two numbers now that multiply together to give negative 5, and add together to give negative 4. Well, that's going to be x minus 5 and x plus 1. Now you'll see that there's a common factor in the numerator and the denominator. It's the number x minus 5. So we can divide the top by x minus 5 to get 1, and we can divide the bottom by x minus 5 to get 1. And we're left with x plus 2 divided by x plus 1. And again, they're in brackets if you want. And don't think at this point, well, we can cross out the x's because the x will cancel with the x. Okay, please don't do that, because you've done all the good work, and don't throw it away towards the end. Now the last one looks tricky because it's a cubic. It's power 3 there. So we haven't done one like that before, and it's the kind of thing that could crop up in an exam or in your workings, and it'd be such a shame if you just didn't think for a second and just said, well, I've never done that before, so I can't be blamed for not getting it right. Look at that numerator and ask yourself, is there a common factor? Well, there is, isn't there? There's x. So I can factor out the x first. I'm going to put the denominator into a bracket. Now, x cubed, what do we times x by to get x cubed? X squared. And what do we times x by to get negative 4x? Negative 4. Now, that hasn't helped us yet, because we still don't have a common factor identified in the numerator and the denominator. It's there, but it's still not obvious. Until you realise, hang on, that's the difference of two squares again. We've done that above. So we can write that out as x plus 2, x minus 2. So we factorised the difference of two squares. And now we can see that there's very obvious, there's a common factor in the numerator and the denominator. It's the number x plus 2. So we divide the top by x plus 2, and we divide the bottom by x plus 2. And we're left with x times by x minus 2, which you can multiply out to be x squared minus 2x if you like, but try and leave your answers factorised, because by factorising you can simplify. So that's one of the reasons we factorise, is so that we can simplify, because it helps us to simplify problems. So factored forms are often the more simple form. Now there are examples where you do multiply out, and when we're solving quadratics you'll see that later on. Okay, so that's the solving algebraic fractions. These are hard questions. If you're doing these at GCSE and you're heading for one of the highest grades, that's fantastic. And if this is the kind of thing as well you need to be good at when you're coming to do A-level. And just one more thing, if you're still finding this difficult, it is something you need to master, so please come and see me. I'm always available to help at lunchtime. I'm either going to be in the maths office or in one of the maths rooms, so do come and find me.